In our NVH testing of the Tesla, the EV vehicle, versus the ICE vehicle, the BMW, we took it on various road surfaces and at different speeds. We've already discussed a smooth road surface and a rough road surface, and both of those were highway roads, and we were traveling about 70 miles an hour. What I'd like to do is take another snippet of road and compare that. In this particular piece, we have a rough section of road that has a speed limit of, I believe, 45 miles an hour. And a couple interesting things we found in that study. One of those things is that the actual sound difference in the Tesla compared to the BMW is almost identical. In this particular graph, we have a 67.404 and a 67.405 dB levels. So that's identical, Tesla to the BMW, about 67 decibels, and as you can see on the graph, equal across all frequencies. So that's a very interesting result that we can obtain through our octave analysis. And that would seem to indicate that when we're on the highway going at 70 miles an hour, there's a lot more wind. And the Tesla is louder under those circumstances because the quality of its build is such that that noise of wind is getting into the cabin, and not so with the BMW. At slower speeds, the sounds of road vibrations must be greater than wind noise, and so the sound of the road vibrations coming into both vehicles seems to be comparable. Now, that's one snippet of our study, and that's perhaps an area of further study, but that's what we're finding, a difference on the highway versus residential road as far as the sound in the cabin. The second thing that is still interesting is whether or not we are studying the mirrors or the strut. There seems to be still more damage and vibration in the Tesla than there is in the BMW. This particular graph is showing the fatigue damage for the Tesla and the BMW. You'll notice that there's a little shift in resonances there, but overall, across most of the spectrum, the Tesla is higher fatigue damage than you're going to find in the BMW. In this particular graph, we're taking a look at the displacement of the windshield, Tesla versus BMW. That seems to be pretty comparable across the spectrum in terms of displacement. And in this particular graph, you're seeing the strut displacement. And here you see a tremendous difference between the Tesla, much higher displacements than the BMW. I would like to just comment on this screen. It appears as if there is a 4.5 inch displacement versus maybe a 1 inch displacement. We ought not look at those as absolute values, but as just relative values. There's a factor that I can adjust in the settings that will change the actual listing here of the displacement in inches, but focus on the difference between the two. And the strut on the Tesla is giving much higher readings than the BMW, even at these slow speeds as it's hitting these potholes on a rough road. So that's our study on the rough road at residential speeds. The takeaways are the Tesla and the BMW have similar noise, but the Tesla has still higher vibrations in the various components that we studied than the BMW. We compared various road surfaces, and one of the things that we are able to do with our software, which is not directly related to what kind of road surface you're on and how fast you're going, is analyze the data and take a look at how the vibrations in one vehicle compared to another. And in this particular case, what we did is compare the mirror, the rear view mirror's vibrations compared to the window vibrations. And we did that for the Tesla, and then we did it also for the BMW, and we can show all of that comparison in the same piece of software, in the same file. And so what you see in this top graph is a comparison of the Tesla's rear view mirror to its windshield. This is a transfer function and or a transmissibility graph, and what you're seeing is a resonance on that mirror. The largest resonance is at 67.3 hertz. Now that's interesting. Companies that make the mirrors know that mirrors as a rule have a resonance somewhere in the 60 to 70 hertz range, and we wanted to compare what is generally known to what we were finding in our tests. And the Tesla's mirror in this particular model had and on this particular data recording that we did, had a resonance of 67.3 hertz. And the BMW, its mirror compared to its windshield had a resonance of approximately 61.5 hertz. So a slight difference in resonances, and you could take a look at your road data of a particular vehicle and make these kinds of comparisons. And if you took multiple vehicles, you could compare them to see what kind of resonances you're finding, not just on mirrors, but on any other part. And there's some of the handy aspects of the ObserView software that we have.